Welcome to my science class. In this class, we'll study the chapter light, reflection and refraction. We'll study the basics, part 1. First, we'll see what are spherical mirrors. So, the mirrors whose reflecting surfaces are curved or spherical are called as spherical mirrors. The mirrors whose reflecting surfaces are spherical are called spherical mirrors. Now there are two types of spherical mirrors: concave mirror and convex mirror. There are two types of spherical mirrors. First, concave mirror. Concave mirror. What is this concave mirror? The mirror in which the reflecting surface is curved inwards is called a concave mirror. The reflecting surface is curved inwards. In the case of a concave mirror, the reflecting surface is curved inwards. See? It is curved inwards. This is the back of the mirror. This is the back part. This is the front part. It is curved inwards. It's called as concave mirror. Next one is convex mirror. Convex mirror. So the mirror in which the reflecting surface is curved outwards is called convex mirror. The reflecting surface is curved outwards. Curved outwards. And show it here. It's a convex mirror. It is curved outwards. It is convex. This is concave. Now we will see the different terms that they use. You can see it's a mirror, it's a concave mirror. This point P is the midpoint of the mirror. It's called as pole. Point P is the midpoint of the mirror. It's called as pole. Pole is represented by P. It is the midpoint of the mirror. P is the pole of the mirror. In the case of a convex mirror, P is the pole. Pole is here. Now, what is the C? C is the center of curvature. Center of curvature. Represented by C. What is center of curvature? It is the center of the sphere of which the mirror is a part. See, if you draw a circle like this, you get a sphere. And the mirror is a part of the sphere. You draw a circle like this, a sphere will get. So, C is the center of the sphere of which the mirror is a part. It's called center of curvature. Then there is a line here. You can see the line here, the line. This is called as principal axis. Principal axis. It is the imaginary line that passes through center of curvature and the pole. It's called the principal axis. This is the principal axis. In the case of a concave mirror, the center of curvature is the front of the mirror. In the case of convex mirror, the center of curvature is behind the mirror because the sphere comes like this. So in this case, C is behind the mirror. Here C is in front of the mirror. Next, this point F. It is the midpoint of CP. From P to C. So this F is called principal focus. Principal focus. That is F. F is behind the mirror in the case of a so now this distance from P to C is called radius of curvature. From P to C. Radius of curvature. R. From P to C is called R. That is the radius of curvature. Next, the distance from P to F is called focal length. That is shown by small f. focal length. Focal length. It is represented by small f. So this is PC is the radius of curvature. PF is the focal length. The focal length from here to here. First is pole. This is the midpoint of the mirror. Next is center of curvature. That is the center of the sphere of which the mirror is a part. Next, the imaginary line passing through the center of curvature and the pole is called as principal axis. This the midpoint of P to C is called as the principal focus. Then the distance P to C is called as radius of curvature. The distance P to F is called as focal length. Now, concave mirror is called as converging mirror and the convex mirror is called a diverging mirror. Why it's called converging? Why it's called diverging? We'll see here. Suppose there is a concave mirror. Let this be the principal axis. So the rays that are parallel to the principal axis, let this be F, let this be C. So the rays that are parallel to the principal axis here you can see the rays that are parallel to the principal axis after reflection they pass through F. They converge through F. The rays that are parallel to the principal axis after reflection they converge through a point, principal focus. So it's called as converging mirror. Now coming to the convex mirror. In the case of a convex mirror, the rays parallel to the principal axis after reflection they diverge as though they are coming from F. They the rays that are parallel after reflection they diverge outwards as though they are coming from this point F. So it's called as diverging mirror. Concave mirror is called converging because they converge. It's called diverging because they diverge outward. Now we'll see the behavior of a light ray when it strikes a spherical mirror. We'll see how does the light ray behave when it strikes the spherical mirror. First we'll take a ray. The ray parallel to the principal axis. Now we'll see how does the ray that is parallel to the principal axis behave after reflection. In the case of a concave mirror, now the ray that is parallel to the principal axis after reflection, it goes through F. Goes through F in the case of a concave mirror. In the case of a convex mirror, in the case of a convex mirror, the ray that is parallel to the principal axis after reflection, it diverges outward as though it's coming from F. Next we'll see the ray passing through the principal focus. How does it behave after reflection? In the case of a concave mirror, the ray is passing through the principal focus and it is striking the mirror. The ray is passing through the principal focus and meeting the mirror. Then after reflection, it becomes parallel to the principal axis. If it goes through the principal focus of reflection, it will become parallel to the principal axis. Here, the ray that is directed towards the principal focus, the ray that is directed towards the principal focus after reflection, it will become parallel to the principal axis. Here it will become parallel. In the case of a convex mirror, this is a concave mirror. This is convex. Now we will see the ray passing through the center of curvature, how does it behave after reflection? So the ray passing through the center of curvature will retrace its way back. See, for example, there is a ray passing through the center of curvature. After striking the mirror, it will go back along the same path. It will go back along the same path. Here also, the ray that is directed towards center of curvature will go back along its same path. Now we'll see the ray that is incident obliquely to the principal axis. So the ray that is striking the mirror at the pole at some angle is the pole. Then after reflection, it will go along the same angle. This angle of incidence will be equal to the angle of reflection. The angle of incidence will be equal to angle of reflection. Then here also it will go along the same angle. This angle will be equal to this angle. This is the angle of incidence. This is the angle of reflection. They will be equal. In the next class, we'll learn some more basics. Please like, share, and subscribe. Thank you.